Hello folks, in this video I'm going to explain how to backtest a trading strategy in Python using the Pandas module. Now the system that I want to backtest is a simple moving average, which is explained on this website here. Now it says that a moving average is a simple tool that smooths out price data by creating a constantly updated average price, and this average can be taken over a specific period of time. Now the chart down here illustrates what's going on. So here you can see the price going up and down, and underneath you see a blue line, which is the moving average. Now this can be set to different time periods, like I said. So a 5-day moving average, for example, would only take the previous 5 days of price action into account, and therefore it would follow the price more closely, while a longer period, such as 200 days, would be taking a lot more data in, so it would be a smoother line and it won't be as reactive to the daily up and down movements of the price. So this moving average line here looks like a more longer period one, and you can see it's quite a smooth line. It doesn't really move up and down as much as the price does. So that's a brief overview, but if you want to read a bit more about moving averages, then I'll put a link to this site in the description. Now, there are a number of ways to trade with these averages, but to begin with, I'll test the moving average cross system. Now, the rules for that are quite simple. First, I calculate a long period moving average, so I'm going to use 200 days. And then when the price crosses above the moving average, I will buy and hold. And then when it crosses back below the moving average, I will sell and wait for the next buying opportunity. So with that explained, I'll just begin coding. Now I'm going to use Jupyter Notebook for this, but I'll upload all the code and I'll link it in the video description. So first of all, I need to start by importing my libraries. The main one that I need, as I said, I'm going to be using Pandas for this. So the main one that I need is Pandas data reader. I import pandas underscore data reader as PDR. And this is what I'm going to use to download the historical price information. Additionally, I need NumPy. So import NumPy as NP. I also need datetime. So import datetime. And lastly, to be able to display some of these charts on a screen quickly and easily, I will import pyplot. So import matplotlib.pyplot as PLT. Okay, and I'll run that line. And for the next one, I need to define some of my variables. So I'll say define variables here. Now the first one is my moving average period. So I'll just call this period. And as I said, I'm going to be using a 200-day moving average. I also need to define a start balance, because if I'm going to be testing the system, I need some kind of money or some kind of balance to keep track of as I go through it. So we'll say start, starting underscore balance. And to make the numbers easy, I'm just going to say 10,000. So it's just going to make everything a round number easier to follow. Next thing I need to do is define my date range. So let's say define, let's get rid of caps. Define time period. So for the start, this is where the datetime module comes in. So I say datetime.datetime, and I'm going to start this and say 2005-11. So right at the beginning of 2005, and then my end period, I'll say datetime.datetime, and I'm just going to test 10 years worth. So let's say 2015. 1st of Jan. Then I need to know how many days that actually includes. So I'll say days equals, and I'll subtract these from each other. Say end minus start. Actually, I'm just going to convert this straight into years. So I'll say years equals end minus start dot days, and then divide that by 365.25 to account for leap years. So essentially, that's given me a start date of 1st of January 2005, an end date of 1st of January 2015. Then I subtract those two, convert that into days using datetime. And then from that, by dividing it by this number, I'm going to get the number of years between start and end. All right, so now I'm ready to actually load in some data. So I'll add a comment here, say load data into a Pandas data frame. Now that module that I've imported earlier, Pandas data reader, is automatically going to download data from me from Yahoo Finance, and it's going to save it into a data frame. So to do that, I will create a new data frame, which I'll save as the variable price. and I will call that module PDR, and I'll say get underscore data underscore Yahoo. And in here, I first of all put in the symbol of the index that I want to download data for. So I'm looking at the S&P 500. So I'm going to put in here GSPC, and I need to supply a start and an end for the time period. So I'll say start and end. And then lastly, just to see that the data that I'm downloading is correct and it's what I'm expecting, I will output part of that data frame. So by saying price.head, I'm going to output just the top of this data frame. If we run this now, it will take a second. It's downloaded all our data, and now you can see that it's printed out the top 1, 2, 3, 4, 5 entries from that data frame, and it's given me the high, low, open, close, volume, and adjusted close. So this is the only information that you would get when you download this using the data reader. Now there's a few columns here that I don't actually need for the system, because really all I need is the open and close. So I'm going to be using these to calculate my daily return, my moving average, and so on. So I can just drop all of these additional columns because I don't really need them. So down here, I'll say drop redundant columns. And to do that, I just define my data frame. I'll say price equals price.drop. And in here, I just need to list out all of the columns that I want to drop. I need to make sure that I use the correct capitalization. So they need to be named exactly. It's case sensitive. So I'm dropping high, low, volume, and adjusted close. Wow. And additionally, I need to specify the axis from which these are being dropped. So the axes here are 0 and 1. 0 is my index, so that's going to be my dates, and then 1 are my columns. Well, I want to drop from the columns, so I have to specify 1 here. And again, just like I did up here, I want to make sure that the changes that I've done are actually operating the way I wanted them to. So I'll just output the head of this again. So we do that, and now you can see it's very quickly dropped all of those unnecessary columns, and it's just left me with open and close. So now let's see what this data actually looks like. I know that this is supposed to be price information, so I should be able to chart it, and it will look exactly like the price chart of the S&P 500. So let's add another row here, say plot chart. And for this, I'm going to be using the pyplot module that I loaded in earlier. So I say plot.plot, and the information that I want is from my price data frame, and it's the close column. So I can access this in two ways. I can either say price and then put in the name of the column, just like I did up here, or I can simply access it almost like a method. I would just put full stop and then the name of the column. And then I need to say plot.show. So this is going to output the chart onto the screen. And there you go. You can see it's taken all of the data exactly as it was formatted here with the dates and the prices, and it's charted out for me. Now you can compare this to the actual price if you go into Yahoo Finance, for example, and you can see the price for the S&P between 2005 and 2015. And you can see that it's going to match this. I mean, you'll recognize, for example, between 2008 and 9, you have this the financial crash down here. So the data is coming in fine, and I know that this information is being downloaded and processed correctly. So now that I'm happy that the data is correct, I can start processing it and actually calculating things and getting some information from it. Now the first thing that I want to do is calculate the daily return of the S&P 500. Now doing that is quite straightforward. I'm basically just going to take the daily close and divide it by the daily open. That's going to show how much it's either increased or decreased as a percentage. So to create a new column within this data frame, I need to define it just like I have done previously when I was wanting to call them. I just say price, square brackets, and then I name the new column. So this one is going to be called return. And to calculate it, I'll take my close price and I'll divide it by the open price. Now what you could do also is to divide the previous, or sorry, today's close by the previous close. I suppose there's two different ways of doing this, but then that's going to take into account any gaps. So because this method is opening and closing on the daily open and the daily close, I'm going to be using these to calculate my daily returns. So with the returns calculated, that means that I should be able to calculate a balance for a buy and hold strategy. So before I actually look into the moving average strategy, I want to know as a benchmark if you invested that starting balance on day one, what would you end up with at the end of it, and how would that balance change as it goes along? So to do that, just in the same way as I have above, I create a new column. I'm going to call this bench underscore bal, and this just stands for benchmark balance. So this is just my, I suppose, the standard return that I would get without any trading system if you simply put the money into the S&P and just left it. So to do that, I need to take my starting balance and I need to multiply it by, now I've already calculated my returns, so I can say price dot return. However, that's only going to give me a column that's taking the starting balance and multiplying it by the return of every single day. So I can demonstrate what's going to happen here by, again, putting out the information from the price. Now this time I'm not going to put out the head because there's not going to be any information there. I will put out the tail, as that gives me the end of the data frame. So that's going to, so this would be the information on the head, and this is the information in the tail. So if we run this, you can see I've got my daily return, which is just my close divided by the open, and then I've got my bench balance. But you can see there's a bit of a problem with this benchmark balance, which is that it's not actually increasing or decreasing. All that's happening, and this is just the way Pandas works here, is that it's taken that starting balance, which is a fixed variable of 10,000, and then it's multiplying it by each entry within this return column. So notice that this number here is simply 10,000 multiplied by the return for that particular day. But then on the next day, it doesn't take into account what happened the day before. It again just takes 10,000, multiplies it by the return for that day. Now, that's not really what I want. I want it to be able to track it and adjust it and basically give me the cumulative balance. So it needs to take into account all of those days. So to do that, I need to keep a running count of the return. I need not just the individual day's return, but the overall cumulative return. Well, to do that, I just add cumulative cum prod. So that's the cumulative product of the balance, of the return. Now, if I run this again, you can see now it's updating correctly. And actually, to demonstrate this, what I could do is display this benchmark balance. So just the way I plotted this price close chart, I can do the same thing with the balance. And because it's just following this price here, it's just buying at this point and then essentially just following the up and down movements of the price, it should give me the exact same chart. So let's test that and say plt.plot. This time it's price.bench underscore bal. And then plt.show. So notice the price looks exactly the same. It's got the same date range, but the y-axis is different. So now it starts off around 10,000, which is that starting balance, and then it finishes up here just over 18,000, which is what I've got in the very last column, or the very last entry within that column. So it's mimicking the price exactly. So I know that this column and this calculation is working correctly. Okay, so now that I know that I've got this balance calculated, let's extract some metrics from this. So for example, how much as a percentage is this actually returning? So I can see that it's gone from 10,000 to 18,000, so I can simply subtract the two and say that it's gained 8,000 money units. But what is that as a percentage? What is that as an actual percentage return? Well, I can start calculating some metrics. So here I can say, instead of this chart, which I don't really need anymore, that was just a test, I can say calculate metrics. And the one I want is my, first of all, my return. So because this is for my benchmark, I will say bench underscore return equals. And to calculate this, I just take the very last benchmark balance and divide it by the very first balance. To access this, I just access it with the index value, similarly as Python lists. So I will say price.bench underscore bal, and to access the last point, you would just say -1. So you would do the same thing in a list. 0, 1, 2, 3 goes through each of the individual rows, but if you count backwards, it goes, or negatively, it goes in the opposite direction. So I divide that by price.bench underscore bal on the very first day, so at index 0. So let's output this, say print bench underscore return, and so it's given me a return of 1.836, and that's fine, but really I want to display this as a percentage. So what I need to do instead is put this in brackets, subtract 1 from it, and then multiply it by 100. Let's run that again. And now I'm getting 83.67%. I also want to make sure that I round this because I don't really need all of those decimal points. So let's round that to, let's say, 2 decimal places. And there we go. Complete return of 83.68% over that over that 10-year period. But what is that annually? Well, for that, I can calculate another metric, which is the CAGR, the compounded annual growth rate. So let's say bench underscore CAGR. Now the equation for this, you can just look it up online, but this is basically how to calculate it. So we say price dot, it's quite similar actually. I take the last point, so -1, divided by the start point. So this will be price dot bench underscore balance 0, so the overall return essentially. But then I take this to the power of 1 divided by the number of years that this has been trading. Now remember, I already calculated the number of years right at the start here when I was defining my start and end dates, and I calculated years way back then. So I can use that already within this equation here. And this is where it starts to get a little bit confusing because I now need to wrap all of this again in another set of brackets, take away 1, then wrap it in another set of brackets, multiply by 100 to convert it to a percentage. And again, I'm going to have this issue with the rounding. So I need to add round another set of brackets and we'll go to 2 decimal places. So I've got my benchmark return. Let's also print the CAGR. So that's showing that it's generating 6.27% return year on year. Now that's a pretty decent return. So you can say that over that 10-year period, if you're averaging that kind of return, that's not a bad return at all. However, as well as looking at the upside, it's also very important to look at the downside. Now we can't really ignore this huge drop from 2008 to 2009. And that's something else that I want to consider and I want to calculate. So that is defined as your drawdown, basically your peak to low distance. So what is the maximum within this trading system? What would be the maximum drop that you would see as a percentage? Now on here on this chart, it's very visually, it's obvious that it went from this point all the way down to this point. However, without this, it would be a bit more difficult to be able to tell, for example, within this date range from 2009 onwards, what the maximum drawdown is. So you can maybe say it was here or potentially there, but there's an easy way to work all this out. So first of all, what I need to do is to be able to track the peak balance at any given time. So let's add a column here. We'll say calculate the drawdown. And I need to add in a couple of extra columns. So the first one is going to be, and I'm creating this the same way as I have been in the past. So I call my data frame and then I define the new column name. So this is going to be the peak for the benchmark. So I've called everything bench balance. I need now the peak balance. So we'll come down here and we'll call this one bench underscore peak. And this is just going to track my benchmark balance. So I need to call bench underscore bal, and I need to know the maximum value. So I will say cumulative maximum, CUM max, and that's going to track within this series it's going to create, this column, it's going to track the cumulative maximum for any given point. Now to calculate the drawdown, I can simply use my balance on that day and compare it against the peak that it's tracking to that point, and just subtract the two from each other. So we say price, and now this is going to be a new column, bench underscore DD equals price dot bench underscore balance. So the balance on that day minus the peak balance. So let's just see what that looks like. Say price dot tail, and now normally typically up to this point I've just put in empty brackets, but I can actually put a number in here. So if I say 10, for example, instead of the default 5, it's going to give me 10 rows. So now I can see a bit more of what's going on. Now I've got my bench balance, and next to that I've got my bench peak. So this is my peak balance as I've gone along. Now you can see as the balance increases here, for example, the peak up to this point it was 18,381, But at this point, it's been exceeded, so I now have a new peak. And that carries on as long as it keeps getting exceeded. But then it drops, and the peak stays where it was. So this column is just a quick way of being able to monitor my current peak value. And now the drawdown is just taking this value here. So on every single day, it's taking the balance on that day, subtracting it from the peak balance. And that's what's giving me my drawdown day by day. So that information is good, and I can see that it's been calculated correctly. But I don't really need daily drawdown. That's not really giving me any useful information. What I actually want to know is, what is the maximum? Like, how much as a percentage has this seen as a drop? So let's calculate that as an individual metric, just as I've done above with these ones. So we'll say bench underscore DD. And here I need to divide. Now remember, I'm looking for this as a percentage. So I've got an absolute value here. So I know that on this day, for example, on the 17th of December, my drawdown was minus 487. And that was off a peak of 18,381. So as a percentage, if I simply divide this by this value here, that's going to give me the percentage drawdown. So I can say price.bench underscore DD divided by price.bench underscore peak. Now I wrap this in brackets because, again, that's going to give me a series. It's going to divide every single value of drawdown by every single value of peak. I don't really want all of those. I just want to know what is the biggest. Well, remember, these are negative numbers because I'm looking for drawdown. I'm looking for negative price or negative balance. So actually, to find out the biggest drawdown, I'm looking for the minimum value. And then again, I need to make sure that I'm getting this as a percentage. So we multiply this by 100, and I need to round it. So I'll add another set of brackets here and round this to 2 decimal places. So let's just make sure that I've done this correctly. Bench underscore DD. And I have not done it correctly. I've missed a bracket here. And there we go. So now it's showing that the drawdown was 52.29%. That is the maximum drawdown. And if we go up here, well, actually, that's the price, not the balance. I would need to print out the balance again, but I suppose you can see that it's effectively the same thing. So the price reached just under 1,600, and then it dropped to, I suppose, about 700-ish. So that is tying in correctly. This is the maximum drawdown that I saw, and it's over 50% of the value. So being able to see these metrics side by side and compare now puts it into perspective, because you can look at the upside and say, well, you can generate 83% over that period from the S&P, but would you be able to withstand losing 50%, well, just over 50% of your portfolio within that time frame? So that's going to do it for this video. I've gone over how to download this data and how to process it, extract some useful information from it, and calculate some of these metrics. In the next video, I'm going to actually look into implementing the system. So now that I have this benchmark set up, I'm going to calculate the moving average, and I will repeat the process that I've done here, but for the actual trading system. And that will allow me to compare between just simply buying and holding and using a trading strategy. So thanks for watching.